want to thank everyone for coming, especially all our outside visitors. My name is Adam Silberstein. I'm an engineer here in the Distributed Data Systems Group. And so today we're continuing our series of LinkedIn Tech Talks, and it's my great pleasure to introduce Pat Helland. So many of you are probably familiar with Pat's work. He's been working in distributed systems, databases, transaction processing for about 30 years.
A little more.
Okay.
Yep.
More than 30 now? Okay.
I had hair when I started.
Okay. So Pat spent time in the 80s at Tandem, and then the mid-90s until just recently at Microsoft, except for a brief stint at Amazon, right? Mostly in architect roles this whole time. So as I was thinking about how to introduce Pat a little bit, I sort of find that the best way to give an introduction is to point you to some of his systems that he's built, and then also his writing and talks. So systems-wise, he's done a lot of great systems. I just wanted to mention a couple of them. So when he was at Tandem, he worked on the NonStop System, the transaction processing part of it. So you can correct me if I get anything wrong here, but the NonStop System is a shared nothing system that aims to do no loss and no downtime OLTP. I think if you look into the details of those systems, you'll see a lot of the optimizations in transaction processing popping up again now in NoSQL systems. I find that to be pretty interesting. And then Pat did a ton of work at Microsoft. I just wanted to mention two systems there, the transaction server and the SQL Server Service Broker. What I find interesting about both of those systems is that they're aimed at giving programmers abstractions for doing transactions, even when those transactions span different software systems or even different databases. We do this stuff all the time at LinkedIn, right? We're always we have large amounts of data that we're constantly moving between systems, and the more we can understand the consistency between them, the better. So then coming to Pat's talks and his papers, I think you'll see a lot of his philosophy in systems architecture there. He makes a lot of connections between things in computer architectures to things outside of computers. So for example, in one of his papers, he was talking about how even before computers, when we had invoices and carbon paper, we were essentially getting unique identifiers and redundancy. And today, he'll be telling us what we can learn about cloud computing from condominium living. So we'll get a first-hand taste of that. Okay, so
Thank
Pat,
you, Adam.
Go ahead.
Thanks. Thank you guys for coming. And so this talk is kind of how I think about cloud computing. I think it's a nascent area. It's something we're still learning about. And I cut my teeth in the time of TP monitors. And so what does that mean? Well, you had all these block mode terminals out there, and you had the mainframe. And the mainframe couldn't run a process per terminal. It was too expensive. And so you found the guys who wanted to do insurance apps trying to write asynchronous programs, and it was just an impediment to progress. And these TP monitors gave you a weird way of programming. But if you programmed to that weird way, you magically went to sleep while it was talking to the terminal in the database, and you didn't have to think about it, and you could concentrate on your insurance application, for example. And so that was a very successful thing. And I think we're in a time where we need that for cloud computing, but we have to talk about what we're trying to do in order to get that. So this is called Condos and Clouds, thinking about cloud computing by looking at condominiums. So outline. We're going to do an introduction. We're going to talk about the drive towards commonality in buildings. We now build buildings without knowing who's going to live in them or use them typically, right? And then we're going to talk about patterns in software as a service applications for the front end, and then patterns in software as a service applications for both the back end and decision support. Then we're going to talk about the drive towards commonality in computing, multi-tenancy making it work, and a conclusion. Let's do the introduction. I live in a condo. Now, I just recently moved to San Francisco, and I'm out looking to see where I'm going to work next after having left Microsoft, and that's where my home was until October when the movers hauled us away, right? Great view, ears popped when going home, but I love living in condos, right? My kids are grown, youngest is 35, so I don't have to worry about a backyard playground or anything like that. I hate working on cabinetry in garages. I don't want to garden, okay? And I love living in a condo. It has its advantages. There's a common heating and air conditioning system that just works. I never get cold showers, right? Infinite supply of hot water. Somebody else takes the trash out to the street. And in 3 of the 4 last high-rises, including the one I'm in right now, there's a trash chute, which is especially joyous because it makes a wonderful racket when you dump stuff down it. Right? And I just viscerally love that, right? And it comes with a building engineer that you can call and say, hey, dude, this stuff's not working, and they come and they just fix it. Now, sometimes it's really nice to outsource a bunch of hassles, but in exchange, you have to live with some constraints. So let's talk about constraints in concierge services. And so if my building type is housing, I might have a concierge that can make reservations and take my dry cleaning and packages, and I have a shared exercise and pool, I've shared engineering, but the parking's limited, I don't have a barbecue, I gotta go over and have my son-in-law barbecue over in the East Bay. If I wanna have barbecued food, I don't get to work in the garage, things like that, right? In an office, we go and we get shared bathrooms and shared lobbies and copiers and stuff, but you have typically a kind of fixed layout. You're not allowed to sleep at work, right? You're not typically allowed to have pets. You may or may not even have a dress code. Some buildings you have to be, dressed in business wear, not where nerds are, but normal other buildings, right? In a retail mall, you have shared engineering and parking and common stuff. And what do you get? You get common, the constraints are common mall hours, constraints on the kinds of retail you do, and only retail activities. And so that's what you get as a part of these package deals when you sign up for this. So my question is, what are the constraints and what are the concierge services associated with cloud computing? How can we build a shared infrastructure that makes our life better when I'm writing an app where I don't want to worry about scale, I don't want to worry about asynchronous programming, I just want to build my line of business application. And so what constraints do I have to have in order to fit into getting the services that are going to make my life easy? Well, let's start by saying, what is cloud computing? Cloud computing is apps delivered as services over the internet or intranet. And it kind of comes in 2 broad categories. Software as a service, which is I'm doing some application and you're coming to me across the network. And utility computing, which is coming at it from the bottom. I'm looking at virtualized hardware and computing that I'm getting over the network, right? So in this environment, I probably want a cloud provider, and most of us think of AWS and Amazon as a very, very good example of that. Providing utility computing, which is giving us an abstraction of computing upon which I write a software as a service application, and then my users come down and talk to me about that, okay? Now, there are 3 new aspects to cloud computing that are fascinating. First, the illusion of infinite computing resources that I can just get more of. Oh my God, the demand has gone up. I need some more computing. Go give it to me. And it just is elastic. It gives it to me. The elimination of upfront commitment. I don't have to buy 100 servers in order to be able to get this going. I sign up for a deal, and as I need them, I go from 1 to 100 to 1,000 servers as I need them. And the ability to pay for the use of computing on a short-term basis. I need it for a little while, and then I'm going to give it back after a while, and my cost is proportional to what I used, not the peak of what I might use. And so that's what we're looking at in this cloud computing world. So cloud computing allows deploying software as a service and scaling on demand without building or provisioning a data center. Now this one slide are pieces I took out of a talk called a paper called Above the Clouds, a Berkeley View of Cloud Computing from February 2009. I think these are really poignant. I think it's a great paper, but this one slide is exactly ripped off from them. And so I want to make sure they get credited for that. But it's interesting to frame what is cloud computing. Now, what are the forces that are driving us to the cloud? One is data center economics, okay? So it is really, really expensive to build a big data center. But the benefits, the amount of computing you get, the cost per computing item are dramatically lower, right? They're very expensive, but the cost for each processor, for each amount of storage, is really down much, much lower. An example is think about chip foundries, right? Every few years, Intel and so forth, there's a handful left, not very many, are making these new foundries that do finer and finer geometries in making chips. Well, it turns out Intel cannot afford a foundry just for their own chips. So what do? They build the next foundry because otherwise they're out of the business, okay? But they also let other people, sometimes their competitors, pay them money to make chips on the foundry, okay? And that's a really interesting phenomenon because you need the foundry to get the thing out of it, right? So there are efficiencies of size in the data center. Electricity, you put it where it's cheap. Networks, you put them on main lines. Containerized servers are very, very much cheaper than racked servers. Shared standard administration of the bottom end of the administration stack. There's the top end that's separate, but shared standard administration. So data center economics is a big force. Shared data. The common big data store. I want to do what-if analysis on every piece of data my enterprise knows about that's my stuff and anything else I can legally get a hold of, and compare and contrast. And we're just continually learning in the last 10 years or so that we are surprised by where the value comes from. But it comes from comparing and combining stuff we didn't think we needed to ahead of time. So we want to put all of an enterprise's data in the common store, store the data, allow the analysis, and see surprises that bring us money. And finally, shared resources. We want to see higher utilization of resources. And what does that mean? It typically means managing priorities so that if something of high priority comes, I can bump aside the lower priority, but then having a notion of lower priority work that can fill in the gaps when the higher priority work pulls back. Now, in order to do that, you have to have standardized usage, and you need to figure out what it means to share that stuff. And you want to do stronger SLAs, allowing that higher priority work to do it. But what's the fungibility? What's the fluidity to allow that to occur? So the three forces are data center economics, shared data, and shared resources. So I'm going to talk about public, private, and what I'm calling semi-private clouds. That name may not stick, but it's just a term that I'm trying to articulate where there's some room for interesting new things to occur. So data centers. Who owns the data center? Is it shared? How is it shared? Physical machines. Are the physical machines shared? If you go to Amazon EC2, the physical machines are shared. The virtual machines are not. Okay? And so if you're running multiple virtual machines, how do you make sure they're not interacting with each other and kind of annihilating the other buddies that are in the same physical machine, right? What's the mechanism for multi-tenanting them? Virtual machines are actually a coarse granule of allocation, and this layer is frequently referred to nowadays as infrastructure as a service, that layer of providing a VM and storage too. Now, platform as a service is ill-defined, but it's something to make the software as a service easier to do that runs on top of the infrastructure as a service, but we haven't really figured out what the hell that thing should be. Right? But we're seeing some examples, right? Force.com, Google App Engine, giving you a programmatic environment that allows you to write your application at a pretty high level and then gives you a bunch of concierge services because of that. And then software as a service, and I've deliberately shown that as sometimes going to the platform as a service and sometimes going directly down to the virtual machine. And there I'm doing web services, or that's a type of it's HTML-based software available to the user across the internet or intranet. So now let's look at where we're seeing these things. In the public cloud, the cloud provider is giving you the data centers, the physical machine, and the virtual machines, and then your software as a service provider is running on top of that. Or maybe the cloud provider is giving you the platform as a service. So I'm going up to Amazon Amazon.com, I'm going up to Google for Google App Engine, and I'm getting all of these pieces out of the cloud provider. If I have a private cloud, I am an enterprise, I have bought some computers, I own the data center, I am taking care of it, and so the IT department has the data center, physical machines, and virtual machines, and then on top of it I may have my line of business app, or I may actually have some platform as a service that's giving some value there. And finally, this notion of a semi-private cloud is not very well defined yet, but the idea is that my IT department is going to go and get coarsely grained allocated physical machines that I can say, this is my stuff and there's no data leakage, there's no stealing, there's no sharing. I've gotten 2 racks out of you, Mr. Data Center Provider, right? And I can call and in 2 weeks I can get another 4 racks, right? And so I can actually allocate my physical machines, but I have to have standards for what they are, and I have to have fungibility for what they are, because the data center provider, the cloud provider, is going to, in advance, allocate those machines without knowing who's going to call up and ask for them. And so you're managing those as a pool, right? And so we're still struggling with how to look at the granularity of cloud computing for this. Now, I like to think about computation for software as a service as being front end and back end. Okay? I got people, they're talking, they get answers, but what's going on in there, right? In the front end, I'm doing calls back and forth with web service or HTML, and I'm giving back the answers to do that. But as I do that, right, and I have to have really strict SLAs. I really want to be less than half a second in order to get back to somebody. As I do it, I'm generating logging information and monitoring information for what the hell happened, which is then being pushed back into my back end for analysis. I'm also going to the internet and I'm crawling and I'm pulling data and I'm creating data sets, right? So you go to Amazon.com, the retailer, okay, and you see them taking their product catalog and price list, which is gathered from literally millions of vendors, and processed and pulled together to give the best impression of what that product is, assuming you can match up with that product. That's all back-end analysis, which is then pushed into caches so that the front end can access it. And so you see this big cycle of stuff that happens when you do a software as a service solution, which involves both back-end processing and front-end processing. So now let's take a pause for a second and look at the drive towards commonality in buildings. Before I talk about common buildings, I want to say that not all buildings are common. Sometimes you have a weird building, okay? It's pretty hard to go to the real estate multiple listing service and buy a steel mill or a shipyard, right? If you want one, you pretty much have to go out and build it. And that's actually kind of true for an IKEA or a Costco, pretty much, okay? But so some of these things are specialized because they have such unique requirements. So I want to acknowledge that that occurs. But what you're seeing is you're seeing different categories of buildings that we've been, and this has emerged over the last 30, 40 years, right? So let's consider industrial parks. We've all seen them. They got a big roll-up garage door and they've got a walk-in door next to it with a little tiny office. And they might be doing automotive repair, they might be doing light manufacturing, there might be a print shop, and somebody might turn one into a delicatessen, okay? They always have one little bathroom, a little office space, and then the back thing with the roll-up drawer, okay? And lots of uses for it. We see convergence into retail, with retail strip malls, with mega malls, with grocery stores. Typically, a grocery store is only useful for a different grocery store, right? It's kind of a little funky. But when you go into, one of the local malls, the spaces that are there are reusable across different kinds of companies coming in and selling their stuff. So many companies can use it. They do leasehold improvements, and then now they're very quickly in there using it. But the structure, the services, the air conditioning, all sorts of things are standard. Security is standard. Parking is standard. You're fitting within the constraints, and you can reuse this thing. It's convergence in housing. Housing is about people. There's many forms of it, but it has people and their stuff. And in order to do this convergence, you have standardized door sizes and electrical connections and plumbing. Not all of us think about the fact that couches are designed to fit through doors, okay? And so very rarely do you have a couch that won't fit through a standard door, because then there's trouble, right? And so all of this has emerged in order to allow us to have standardized housing. If you went back 150, 200 years ago, none of that existed. The door sizes were different, the couches were different, it was like whatever, right? And so it's designed for compatibility with people and their stuff. I don't know if you've ever been into a round house, but my aunt has one, and the furniture doesn't fit against the wall. It's really kind of a drag. Okay. Convergence in office spaces. Office work is about people and information, people getting in and out, and so the building requirements for offices are consistent. We generally know that we need a certain number of bathrooms for a certain number of people and a certain number of copiers and coffee machines and so forth. And so both skyscrapers and suburban, kinds of offices like this one are have a standardized usage pattern, and you can sometimes customize the space within it, but it's all pretty much consistent. So there is a drive towards commonality in buildings. We make the buildings without knowing who will use them, but we know how they will be used. We have a prescription for the usage pattern for them. And so the custom buildings are less and less common. Custom houses are less common. Custom office buildings are less common. Custom retail is less common because of the economics for it. Okay? Now, commonality comes in many ways. It comes in usage patterns and facilities, and it comes in connections to common utilities, right? The custom buildings still have to connect to the common utilities, and that's going to be true in software when we talk about it. You may build a funky custom app, but it's somehow got to fit into how you're managing all of this stuff. Okay? So now let's, again, shift gears and talk about software as a service and look at the front end and look at what the patterns are for supporting web requests or HTML requests coming in from the outside and making a scalable, fault-tolerant, highly available environment the way we need to for most internet offerings. So many services fit a pattern. The request comes in and it invokes a service. Now, that service may or may not go get some session state trying to remember something to do with the last thing we did talking to whoever the hell we were talking to for some definition of whoever the hell we were talking to, right? Okay? And that's a challenge in and of its own right. You may talk to another service and get an answer. You may go and look in a data cache, and that data cache is like the Amazon example of the product catalog, the price list. You have the identifier of a product, you go out and you get all the description, you get all the reviews, you get the photo for it, you get all the stuff and you smash it up onto the screen. Okay? And that's all done out of a cache which is somewhat out of date, which is being filled in with knowledge from the back-end processing. Okay? And then you send a response back. This pattern happens over and over and over again when we're dealing with the front ends, okay? And I'm going to say it's a lot like building in a condo. It's a usage pattern, and we can bring value when you have that pattern. So what value can we bring? We can do automatic scaling. As the workload rises, we're going to add more resources. When the workload drops, we'll take the resources away. We can do automatic placement by doing deployment migration, fault boundaries, geographic transparency. Oh my God, I got this traffic over in the eastern part of the United States. I better put some of this stuff over there to make sure that I'm managing it. And the application shouldn't give a crap. Okay? Capacity planning. Whoa, crap, look at this. Look at the trends we're going. Oh my God, what's going to happen when we get to December when retail peaks, right? Or January when photo sharing peaks, right? What's going to happen? How do we plan the capacity? Resource marketplace. So I have a web service call or an HTML call, and it calls this, and it calls this, and it calls this. How much did that cost? How much computing resources should I accrue to doing that work? And so that I can actually allocate that and decide, is this the right thing to do with my computing resources? A/B testing and experimentation. Most of us who are doing websites out there in the world, you get an idea for how it should be different for the user to see. You only want to take 1% or so of the people and then see what happens if I give them this. Do they click on it as much? Is this going to be as happy? How do we automate and manage that stuff for them? Auto caching and data distribution, product catalog and price list stuff, that equivalent or whatever it is, right? There's a ton of data that fits into this world. I want to generate it. I want to push it out into some pub sub environment, and I want to make sure that it goes out into the caches where it can be addressed magically by this code that's running. And finally, session state management. If you can define what the session is, can you put down the information about what you've seen so far so that when the next thing comes in load balanced over there, I can go get it and keep going where I left off, transparent to the user because my knowledge got transferred into the session state manager. So, digging deeper into some of these, let's look at the stateless request processing. In comes the work. I need to find some computing resources that can handle it and then drive the work into them. At this point, we consider it to be stateless. So now I'm going to load balance it across a set of servers. You've all seen this stuff. This is part of the magic that we can do. Composite request processing. This calls this, calls this, calls this, calls this. How do we do that in order to give back the answer to people that is going to allow us to piece things together? In many of these websites, you can see hundreds and hundreds of calls before you get back the answer. And in some cases, they piece it together out of the HTML, and you can watch the answer coming back together on your screen as different services have answered at different times with different responsiveness. Now, this leads us to this world of SLA and request steps, right? I have a service level agreement for each of those services at each of the levels of that call stack. Am I meeting that SLA? Is the response fast enough? Now, if I'm going to have a system-wide SLA, I need tight component SLAs because I've got a multi-level call graph in that service structure. So what do I mean by an SLA? An example SLA is 300 milliseconds, 99.9% of the time, assuming I've got a traffic load of 500 requests per second, which is piddly low, right? But it's you have a number of a request rate. And if I have cross-service dependencies, it gets even nastier. You always talk about percentile SLAs rather than average because average allows too much skew, which then kind of screws your customer. And so if I have this picture and I have that SLA, that one's tighter, that one's tighter, that one's tighter, that one's tighter, and that one is a real bitch, okay? Because you damn well better be fast in order to make the SLAs that are farther up on the stack. And so there's tons and tons of pressure on the bottom of the stack, and you need to answer that fast and predictably. Today, engineers manage these. They work their ass off to make the code fast, but then they also have to tweak and kick and prod and figure on utilization and manage the bottom of the stack even more than the top of the stack in order to make this happen. That's stuff that can and should be automatable over time. So pounding on the services at the bottom, the deeper the call stack, the tighter the SLA. Session state manager and the auto cache manager get called a lot, and they have to have very tight constraints. So this can result in needing to sacrifice the utilization. How are you going to provide tight SLAs? A short minimum response time, really low utilization, or both? I mean, we all know that the utilization impacts the response time, right? If you run the thing at 50% utilization, the answer is going to take twice as long as if, as twice the minimum response time when the thing's completely unloaded. And the busier it is, the longer your response time is going to be. So why can't we do automatic provisioning to meet SLAs? The plumbing knows what it needs. There's a graph that can be tracked by the system. The end user facing services are configured, and based upon the demand of the calling services, the desired SLA can be calculated. Now, I understand this is hard. I understand we're not there yet. But I also know that if we don't target this as a service for our components, then we're never going to get there, right? But this is an example of if I know the standardized pattern of the call graph, then we can build stuff into the system to manage this. So within limits, the SLA for a service can be met by increasing the number of servers, which drops the utilization, and then dynamically does it. Now that's only within limits. You may find that the minimum response time is so bad you got to get the engineers out to make it a little bit faster. That technique is useful sometimes, but not for everything, right? Okay, accessing data and state. When a request lands into a service, it initially has no state other than what arrives with the request. And it goes and fetches the session state, fetches the cached data. So when you go and fetch the session state, you fetch it using a session key. And when changes are made, you store them back using that same session key, whatever you're going to call it. It's something, I just called it a session key, right? The cache data is fetched from the manager using some domain name and key, and it's used to store the data, and that's a read-only instance for the front end. The back end is stuffing it, the front end is reading it only. So how can you manage scalable and reliable state? Well, you have a session key, you scale with it, the plumbing manages the durability, and you need to figure out how to make that automatically provisioned and managed in your system so that all of your different services can share the same session state. You have to ask yourself, do I want them to share the same session state manager, right? Or do I want to give them individual ones? But it's the more you can share it, the more dynamic the system can be and the more it can tolerate variation. So if I have automatic services, state, and data, then the apps using the plumbing code worry about their business. They go and get session state, get to the cache, do their work, call the other pieces. They implement the business logic and don't worry about all of these things having to do with scaling and load balancing and so forth. These applications build their apps in two pieces, the back-end feed processing and the front-end web processing. We've looked at the front end, we're going to look at the back end here in a second. And the plumbing should say, this is how you use it. You are coming to work, you're coming to live in an apartment building, and you cannot barbecue in the kitchen, right? You cannot make a swimming pool in the living room, right? These are things that are constraints. Here's how you use the front-end software as a service support, and because of that, we will do these magic things for you, okay? Very much like being in a condominium. Now, how do I apply those changes to the back end? Sometimes I am doing front-end work and I'm calling into a back-end saying, I want to make a change to the data. Sometimes I do it indirectly by queuing some stuff, right? So synchronous, I can actually go out and you can think of updating the database. Of course, now that's challenging when you have a scalable world, right? We could talk about that. And sometimes I just enqueue something which then asynchronously processes it against the back-end stuff. Sometimes I'm just logging and capturing information for what did people click on for subsequent BI analysis to figure out what's going to work well. So now let's look at the back-end a little bit and how do we do back-end and decision support stuff. Typically, you see changes coming into this back-end from internet crawling, data feeds, and user and system data that came from the front end. Those are the typical areas that you see changes. You also can see work by having the front end say, oh man, I really want to go and change that data because my user said I want to go change the data. Okay? I know in LinkedIn when you update your profile, this is an example of that, right? Do I want to do it directly or do I want to enqueue something that's going to process it in a batch later on? Right? But either way, there's a direct user action which is causing me to update that backend. Okay? How do I generate reference data for the front end? Right? Again, product catalog, price list, crawling, the graph, the connectivity graph that LinkedIn does, things of that nature are all back-end processing that are created and then pushed out to be used by the front end. So data publications and update. The back-end model for data is I get the web data and I process it. It comes in from the outside. I run some app code, either batch or event processing, and then I'm automatically distributing it out to some scalable caches, which the service and the stateless service access it. Now, I am 100% comfortable with batch processing for the application. I'm also comfortable with the trade-offs of trying to lower the latency of an event that occurs. Something comes into the back end and you want it to show up on the website in 1 second, 10 seconds, an hour. What is it? There's the discussion of how to not do that as a batch, but do that as an event processing in the back end. Both are very important and powerful patterns. So let's zoom in on the reference data cache that's stuffed. So we'll look at that in a little more depth. The typical way of doing this is partitioning it and replicating it. And here is a very simple model where we've created the partitions and then we've created the replicas. Now, you partition for data size. You replicate, in this case, which is not about availability, you replicate for throughput of reads. Okay? And I'm totally comfortable with the Dynamo style mixing everything up and mixing replicated and partitioning, but this is a simple picture to cover what you do here. And so I have automatic pub/sub distribution. I want to stuff that stuff out there. I want to allow the reads to come in. This making sense to you guys? Okay. So the plumbing should provide easy to program back-end processing of feeds and crawls, auto data partitioning for scale, automatic distribution, and pub-subbing it out and getting it out there, and auto-replication of the requests for scale. And again, this is just one way to do it, but the requirements are make this stuff magic, because the app developer shouldn't have to worry about it. What are the styles of back-end processing? How can I think about that? I got the crawling, I got data feeds, I got user system logging, I got front-end calls, I got the back-end outputting reference data caches, front-end responses, analysis results, output data to feed other caches. So we can implement that with a relational database and a quote normal app, N-tier app, Doesn't scale past a certain point, but it's certainly on the punch list of options, okay? Big data in parallel batch, or big data in event pub sub. Big data meaning some form of scalable data representation, which probably doesn't have the full-blown relational semantics, and then we can have a whole many discussions about that. But this is typical patterns you see in the back end. So, if I dig deeper into relational DB and normal app, you know, I may have a DB trigger, N tier, other app, and that relational data is replicated to the big data store. It has the advantages of relational. It also has the advantages that you can more easily get application programmers who can solve your problem. That's one of the bitches, is how do I get normal people who can solve the back-end problem. Parallel batch, that's typically set-oriented, massively parallel stuff. If you hear MapReduce, if you hear Hadoop, if you hear Dryad, which I was used to inside of Microsoft, you know, that's great stuff. Having a high-level declarative language on top of it is great stuff, right? But you want to be able to go at, the more everything is in one big sludgy pool, the more you will be surprised with the value and the serendipitous results that someone will come up with by comparing and contrasting, you know, what day people went to go get beer and what the diapers they pulled out and all of these apocryphal stories that we hear about where people learn surprising information by comparing things. And then big data and event pub sub, right? The incoming work processed within seconds. I've got some queue. I'm processing the queue. I'm whacking on the data. I'm doing massively parallel transactional record updates. It's really interesting now that there's been some technology that Google published with Percolator for how to do petabyte scale transactions, distributed transactions, without being brittle and fragile. And I can talk about that separately if you want. But rapid processing of events into that fresh reference data. What do I get for the back end? How do I get my concierge services? I want unified data access. I want one big pool of stuff across my enterprise, and anything can be processed with anything, assuming it's authorized. I want to allow relational databases for silos and services supporting some of the enterprise work. I mean, you guys aren't seeing that so much here at LinkedIn, but I want to run my, you know, accounting app or whatever the way it has been done for 30 years because I haven't changed it yet and I haven't gotten there. But I want to take the data out of that and stuff it into the big data store because I want to be able to analyze it while my application is continuing to work in its legacy environments. Fault-tolerant scalable storage, cloud-managed stuff for big data and, you know, automatic intra and cross data center replication so that you can walk in and go, and things just keep going. I always think of a good data center as whack-a-mole, right? I should be able to go, and it pops back up, right? And I also believe that if you aren't having enough failures, you're spending too much on hardware. You absolutely need to run on top of crap because it's cheaper. Okay. Massively parallel batch and event processing. High-level set-oriented operations. The incoming events call pub sub, and then it pushes it out. How can I do that massively parallel batch stuff? Automatic scalable reference data caching and pushing it back out. Multi-tenanted access control. Okay, so what do I mean by this? I have event processing, I have batch processing, I have a ginormous pool of compute resources. I need to say how I allocate computation to different departments or different companies or different pieces of things so that I can say, no, you filled this up, or you're not as important in terms of the priority, and I will push you down in order to make sure this guy that's got a higher priority to the business, his needs are met. And managing that multi-tenanted access for control of the data and processing of the data is super duper important in this world. And then finally, prioritized SLA-driven resources so that you can have all of these things in one big soup and make it work for the company. All of these things we can do as services for the app developer. So let's talk about the drive towards commonality in computing. Silos and SOA. So we have these silos of computing traditionally, and we called them service-oriented architecture as we would try to figure out how to do messages going in and out of them. And it's a really interesting way to bring stuff that used to be standalone together as we try to pull things into working together. And so in this environment, I have a set of apps that are running on a database and another set of apps that are running on a different database and so on and so on. And they don't really work together really well. But the only way they're working together is either by doing messaging, back and forth, which is not as common, or by doing, extract, transform, load, taking massive copies of data and, batch copying it over there. But there are ways of pulling this stuff together. But what we want to do is you want to drive those silos and SOA to commonality in the cloud. So the relational database is supported because I've got the legacy of it, because it's there and I haven't killed it yet, if nothing else. But I can do that on top of a shared storage environment, okay? And maybe not transparently, maybe I'm working off of snapshots of the data, maybe I've copied it off, but I can and should be able to get at older versions, maybe not very old, of the data for analysis. But I got to be able to run my existing apps while I move forward. I have messaging and data feed that flows through the big store and potentially across the silos. And then I need to have a standardized monitoring and analysis so I can look and see what things cost and figure out how to change things. So what do I mean by databases and big data, right? The relational stuff, people are using it. There's an incredible investment in it, 30 plus years investment, right? But yet we're seeing GFS and HDFS style massive scale, common namespaces and hundreds of petabytes of data, literally, right? Pushing into exabytes of data. And so the big table and HBase stuff give you very nice updatable key value stores. How do you relate this write once immutable GFS stuff to the updatable store? Percolator style record-oriented transactions are also part of what's coming in here. Massively parallel MapReduce, Hadoop, batch computation, concurrent event processing, and I need to prioritize my allocation. All of these are in the big data stores. So I want to take the relational data and to be able to analyze it. And my argument is that these pieces are coming together and we need to bring them together while respecting the install base of the applications, because otherwise you're doomed, right? You can't discard the applications and how difficult it is to move them. So fungibility and sharing of resources in a cloud. I have fine-grained stuff, I have coarser-grained stuff. If I have resource application, can I share things at a transactional event or a web service event, or do I actually need to go and get a full physical machine like I would to allocate a database? Or can I allocate about a virtual machine? The granularity of the piece of sharing, as it gets finer grained, I am more fluid in my ability to manage the resources, okay? Similarly, when I talk about the data resources and the addressability of it, is it only addressable in the database? Is it addressable in the enterprise? What's the schema look like? You see SQL schemas are prescriptive. It's here's how the record looks. What we're seeing more in big data is at the time I wrote it, here's what it was at the time I wrote it. And so I talk about prescriptive schema versus descriptive schema, and we're clearly driving towards the latter, driving towards descriptive schema as we get more and more of data in that category. Now, there is a natural tension between line of business and IT departments. The IT departments have to manage this crap. The line of business wants to get stuff done to make money, okay? And they want to change things quickly, right? And I'm arguing that that's very much like city governance. I want to build a building, I just want it to be cool, I want it to do this stuff, I'm going to put it up. And then the city says, you got to make the sidewalks this big, you got to do this, you got to do that. There's these things in downtown San Francisco where I live, which is POPOs, privately owned public open space. So if you're going to build a big space, you got to make places people can go and visit 9 to 5. Right? It's privately owned, but it's publicly open. Constraints that San Francisco puts on it. Each IT department has their constraints, and there's this natural tension. What I think is that these patterns for cloud computing can lower that barrier of complexity by describing what the IT department needs to manage and the ways in which the application is built in these patterns. And then within the patterns, it's easier for the line of business to crank out their application, and it's easier for the IT department to see all of these applications with a commonality that allows them to manage them in a similar fashion, okay? Multi-tenancy, making it work. We are getting through this, and we're almost done, okay? Landlords, management staff, keys, and privacy. When you rent an apartment, you pretty much understand that the landlord's got the key. You do, right? And you know, if you own a condo or you own a house, you know, the landlord in the engineering staff of a condo has that key, and they have it for good reasons. A flood is a reason to enter. A fire is a reason to enter. There are emergencies for that. And in some environments, you give them permission to enter so that they can simply place your groceries in your refrigerator for you when they get delivered, okay? And it's kind of nice if you want that, right? Renting or leasing a property implies a bi-directional trust relationship. The tenant has to follow the rules, not trash the property. There's trust associated from the landlord to the tenant. And the tenant is also trusting the landlord not to come in and, you know, break in and do stuff. And if they do, if they come in at the wrong time, there's a world of shit for them, but there's a trust relationship there. It actually took years for these laws to be established. Years for it to be established that the landlord could not just come in just 'cause. They wanted to see what was in your medicine cabinet, okay? And now there's laws that say you can't do it that way because it went through legal precedent to protect the rights of tenants. Common carriers, protecting the provider and the consumer. So the common carrier laws in the United States first applied to railroads. And one of the things they said is, no, you can't favor your friend over somebody else in terms of the price you charge, because you're gaining access to so many things, you have to be fair. Now, you can do volume discounts, but you have to have a policy which is standard and common because you're kind of a utility as a railroad. You have to protect the customer, and if you don't keep them alive, if you don't give them comfortable, if you don't do all these things, and this is very much what you see with the airplanes lately and the fuss over whether they can lock you up on the tarmac for 12 hours, is all part of the common carrier discussion, right? But there's also protection for the provider, right? The common carrier gives a service and is not responsible if that's used for illegal purposes. There were serious legal battles in the 1930s when one gangster got on the telephone and called up another gangster and coordinated the robbing of a bank. And then the phone company gets hauled to court as a co-conspirator. And then people had to scratch their head and say, well, really, you know, if we're going to tell them they got to let everybody use it, they can't be really blamed as a co-conspirator in this case. Okay? This took time to establish. The condominium laws in the United States, the rights, responsibilities for developers of the buildings, owners of units, and homeowner boards are fascinating. I've been on homeowners boards. It's really interesting, the crap you have to deal with and what it's like to do this stuff. So I'm arguing we need clearer laws about the rights, responsibilities, and protections for all parties in cloud computing. Now, this is less an issue when the enterprise owns the cloud, the private cloud, and more an issue when it's being shared across. But even inside enterprises, you see the definitions of what one department can do to another. And all of this is up in the air, okay? Nobody's figured out what it really means. So if you go back and you look at public-private sharing and trust, the public clouds, I'm giving multi-tenancy across companies. You know, typically the granularity is files and VMs, but if you go to salesforce.com, they have finer granularity. They share records in a database. Multiple companies are working on the same Oracle backend database, and they're getting in and out and working on the same stuff. And so the cloud user has to trust the cloud provider with their data. And if the cloud provider is a creep, then your data is in trouble, right? And so you have to decide, do I trust that person? But I want to point out, we trust AT&T and Verizon and all of these phone companies not to eavesdrop. Why? Because the laws send them to jail pretty handily if they wiretap, except when the federales want to do it, okay? And so now you end up with these hybrid, enterprise deployments. Some app is at the IT center. Some app is up in the cloud, right? I want to do that so I don't have to buy everything ahead of time and I can surge up into the cloud when I need it, right? How do we know that we can trust that cloud? How do we know we can push that work up there? And again, in the semi-private cloud, I think that that's going to be an interesting point because we can leverage the expensive data centers and give you cheaper resources within the expensive data centers, but literally wall a rack off and put VPN between them so that you can stand in front of the judge and say, dude, yes, I put HIPAA medical data in my semi-private cloud off in his data center, but here's the reasons why I wasn't violating HIPAA. Here's the reasons why I was living up to my fiduciary responsibility in the care for that data. These are issues we haven't completely resolved yet. Conclusion. Defining constraints and empowerment. Programming platforms, they have APIs, right? And they give you a model for how do you do it and how do you use the platform support and different models for use, different platforms have different models for use and support. Shared buildings have expectations for usage. And it is more common than not to build the building before you know who will be leasing the property and moving in. Okay? That's true for retail, office, and housing. Right? You build them with an expectation for how they will be used, but not for who will be using it. Right? And that's a really interesting thing that we see. Now, we need to define the expectations for usage if we're going to define platform as a service. Right? And I want to emphasize, this does not need to address all classes of computing. I am totally happy if a platform as a service doesn't help with weather simulation, right? Because that's weird shit, right? And that's fine. They can go and run on the VMs in Amazon and write their own stuff. But, software as a service, web service calls, I think that's a pretty interesting thing to target for platform as a service, right? And so we need to design that platform without knowing who will occupy it, but know how they will use it and what concierge services we can give them associated with those acceptable constraints. Again, front-end concierge services, auto-scaling, auto-placement, capacity planning, resource marketplace, A/B testing and experimentation, automatic cache and data distribution, and session state management. The concierge services for the back end are big data unified data access, run in relational databases on top of for the silos, right? Fault-tolerant scalable storage, massively parallel batch and event processing, automatic scalable reference data caching, multi-tenanted access control, prioritized SLA-driven resources. All that stuff's important. Now, condos impose constraints. My kid brother lives down between Morgan Hill and Gilroy, and he has pet chickens on his 3 acres. I don't raise pet chickens in my condo. I'm not allowed to, right? Condo buildings are designed with an expectation of usage. Density, lifestyle, restrictions, can't make too much noise, right? But I got an exercise room, and I got a wine storage locker, and I got nice parking with valet help, and there's all these patios and stuff that's really nice, right, that I like. But it is those constraints. It's the fact that I'm told what I cannot do that allows me to have these shared services. And that's an important point to carry from this. If the constraints aren't right for you, condo living isn't right for you, and you should not live in a condo. But I still don't want to mow the lawn. So, what about those forces? Data center economics, right? If I want to do a public cloud, I have to trust the cloud provider, right? If I want a semi-private one, then I have less trust because I can really define very coarse-grained things that the cloud provider will do for me, not the fine-grained multi-tenanted, it's coarse-grained multi-tenanted. So we'll see what the heck happens with that. Shared data. It's clear to me we are going to evolve towards all data in a big data store within one enterprise trust environment because there's so stinking much money in comparing and contrasting and learning from the data. Shared resources. We can have coarse grain sharing, much like you see with Amazon.com, Amazon AWS, right? Or can we do fine grain sharing where it's the individual web service requests, it's the session state that's going into a pool, it's the things that I'm pushing into the data cache that I'm sharing, right? And what's the boundary for that? How can I manage SLAs across that? We haven't done enough of security, identity, SLA management in these environments yet. So, takeaways. Whenever I do a presentation, I try to say, what the hell do I want people to remember, right? First of all, shared buildings became successful by constraining and standardizing usage. Changes in usage pattern, expectations, and the law were required. Standardization will empower migration of work to a shared cloud. Shared in a company, shared across companies. But it's very important to be able to have different classes of standardization to allow approachability of things. VMs are coarser grained. I think we can do finer grained stuff and get even more value. We have to define the constraint models for important types of cloud apps. And enterprises can gain tremendously from public and or private clouds. Sharing apps, driving towards fungible resources, using the cloud to clarify the relationship between the line of business and IT, and those concierge services empowering IT and liberating the line of business from worrying about it. And that's it. Any questions? So do you think I'm full of crap? Questions? If you could go to the microphone, it'd be great. If not, I'll repeat the questions. Are you guys stunned and lulled into, is it a great soporific? Or? Yes?
So you talked a lot about laws for making clouds, I guess, trustworthy. By laws, do you mean legal laws? Or
So I talked about laws for making clouds trustworthy. Do I mean legal laws or technology? If I'm going to trust a public provider, which is an independent company, with healthcare information, I need to know that if they lose it, I don't go to jail. And, okay, so pushing encrypted stuff, it's easy to stand in front of the judge and say, dude, I encrypted it and it's just a bunch of mash. Okay, I'm not going to go to jail if I back up my encrypted data up in the cloud, but I sure as hell am not going to do some very effective computation across it either. So the question is, can you do isolated silos of encryption and decryption? I would love to see those things demonstrated, but I also want you to realize that the hallmark I have is if I am in charge of that data, will I trust my next 20 years in the federal institution being locked up because the cloud provider screwed up? Will I trust that technology that much? Right now, I know how to trust a data center with a chain link fence around it and security guards. Okay, that's what we're competing against in terms of knowing that I've lived up to my responsibilities as the caretaker of data. That's the point I'm trying to make. And I'm not saying no, I'm saying, you got some convincing to do before I buy into this, little decryption thing right there. But there's also the question of, what are the expectations in our community, in our country, in our international environment for living up to my responsibilities? And these are issues that are keeping most people from using the public cloud. Okay, but they use it for other stuff. They use it to test things. They use it for, so it's growing like crazy for stuff that isn't going to get me locked up if it goes awry. Does that make sense? Okay. Other questions? Come on, it can't be that cohesive or maybe totally irrelevant. That's what it is. Yes?
So one question is, so some of the regulations that we talked about how we're going to use an apartment complex or how we're going to use an office building, what I've noticed in the real world, a lot of them are kind of very soft limits or soft codes. So for example, my neighborhood says that I cannot have my apartment complex says I cannot do certain kinds of grilling, which means, but the thing is, if somebody does kind of violate that and runs a small grill, generally that's not going to be an issue. Versus in a cloud service, in a shared service, let's say.
So let me catch it for the recording. So the point is that in many environments, like in the apartment complex, there's soft limits. You're not allowed to grill, but people do it anyway. What the hell? Did I catch it so far?
Right. Now, let's say you're adding something within you're providing a shared data source for your company, and the thing is, you're trying to limit somebody who is, you're trying to limit applications from overloading a resource or doing something which is kind of not.
We're totally right. So how can you do shared resources and limit people from overloading a resource and make it be kind of soft? And we're still learning about that. Did I catch your point correctly? Yeah, and so we're still learning about how much flexibility you can give, but that's not any different than 101, okay? You can get, I live in downtown San Francisco. It might take me an hour to get home or it might take me 2 hours to get home. I just don't know. And that's not all based on accidents. That can just be based on you hit a limit and something goes awry. And so this now turns around into what's the cost of using the resource, and do I want to do filtering at the beginning to ensure that I'm not going to exceed the capacity, right? Or do I want to do probabilistic overbooking right? And push things in there and know that, 99.9% of the time it's not a problem, and the 1 out of 1,000 times when it is an acceptable cost of doing business. Now, when that sharing is across different companies, now you get into the SLA the cloud provider is providing back to the user. And we are still exploring what that means. So far, public clouds say, good luck, baby. Have a nice day, right? And it's still interesting enough that people come. But then again, so does 101. 101 says, good luck, baby. Have a nice day. And you get on.
So that's, but the thing is, a lot of the SLAs, they'll say your latency is going to be this figure, but if somebody can abuse some by say,
You're absolutely right. Multi-tenancy, how do you prevent the different tenants from screwing other tenants' SLA? Okay, and that's already the case when you're running VMs against a physical machine. It's not normally, but it can be, right? And it's pretty hard to figure out how to really constrain. The only way to really constrain the VMs from not screwing each other on a physical machine is to make sure that you don't use the whole damn box, right? And that's got its own problems. Am I making sense with that? So am I hearing you correctly?
Yeah, you're hearing me correctly.
And personally, I believe we'll end up with a stratified category of it. We'll have hard SLAs, which waste the utilization because it's a good business decision, and we'll have good luck, baby, which will be a much cheaper form of computation that you'll put your lower priority stuff on. And I think that's a reasonable thing to do. And that's not terribly different than Southern California's pay freeways, right? It's like, I can afford for the non-congested, private toll road, and I'll pay for my way on there, but the folks who don't want to pay that are like in a traffic jam. But that traffic jammed freeway's got a lot of utilization. Not a lot of throughput, but that's a different. Yes?
Do you find that cloud computing providers share your vision of the legal side and also on the platform side, just ready to look at these standardized
So do I...
and offering that?
So the question is, do I find that the cloud computing providers share my vision? Well, I haven't had extensive discussions with them, frankly, right? I mean, so yeah, I worked at Microsoft, but I was working in a different division than Azure, and so they're doing their thing, and that's kind of cool. And with respect to, so sharing the vision in terms of what platform as a service is going to be like, and I will point out too, the legal issues, some of that thinking did come from the Berkeley paper Above the Clouds, right? And I strongly recommend that 2-year-old paper, 3-year-old paper is really interesting. It makes you thought-provoking. And so they made me start to think about this stuff, but it's very, very clear that we have to have ways of defining what the sharing is. And I think cloud computing is so young that we haven't figured that stuff out. Did I answer your question?
Yeah.
Yeah. Yes? So what are the success factors for operating a private cloud? So you go back to those elasticity comments that I made early on about illusion of infinite resources and so forth and so on. You want to be able to do that within your enterprise. So the question is the granularity of the trust, right? So I'm trusting across departments and maybe prioritizing across departments, but it's all within my big company that I'm doing that. But at the same time, I have elasticity. So this, I have to do the reporting at the end of the month, and I do this at another time of the month, and now I can share those resources more flexibly. And so, but it's because it's a smaller pool, you typically get less efficient sharing than in a public cloud would over time. Yep. Yes?
So auto-scaling is a very nice property. What trade-offs do you think we'll have to make in data consistency to make that happen?
So the question is, auto-scaling is a very nice property. What trade-offs in data consistency do I think we need to make that happen? The auto-scaling I spoke to was about the stateless front-end web server, and that's not a consistency issue. Okay. The auto-scaling in terms of data, I think we have a knob that we can choose with, I believe in the cap conjecture. I can talk to you for hours about the cap conjecture. I could talk to you for hours about eventual consistency. I have talks about them, right? And personally, I think most of what we do, we want a relaxed consistency model. Now let me pause for a second. The other auto-scaling I talked about was the caches for the data stuffed by the back end to be read by the front end, correct? That was where I used auto-scaling. So let's look at that example. By definition, that reference data is somewhat stale. It's just, it's versioning and it's evolving over time. And here's my description of this product. Oh, and I made some changes. And here's the new version of the description of the product. Okay? And it actually works out when you talk about rolling that stuff out, in the vast majority of the time, it doesn't matter a lot in that read-only to the front end, stuffed by the back end, which version you have. Okay? It's just soft as can be as to the pace with which that rolls out to be seen by the guys who are randomly probing a machine that has a cache in it. Okay? And so you can actually allow that to jitter for a while the replicas are being updated. And I go and I get the new one, I go and I get the old one, I go and I get the new one, and that's fine. And so the question becomes defining the semantics that the app expects out of that cached data and the usage pattern for that cached data. And so I actually think eventual consistency in that world is really, really nice and very neat, because you can get much better management capabilities. Am I answering your question? I mean, Dynamo's a really interesting product. Okay. Yes?
So we live in a hybrid world where you think of uploaded batch data that is
I'm shocked.
updated. And stuff that is primary data, the user hit a submit button to affect.
So let me,
They expect to see what they just did reflected back to them instantly.
I understand. So let me repeat. So LinkedIn lives in a hybrid world where there's stuff which is loose and then there's stuff where the user changes it and then they expect to see it when they look real quick.
Yeah, and so there's a read after write.
There is a read after write consistency.
Very important. But the fact that I just updated my profile, I expect to see the page refresh show my.
Is that right? So if you update your profile, you do expect to see it. I'm going to push on you.
I expect you to see that.
Hmm?
I don't expect you to see my page.
No, I understand, but you expect the updater the guy who updates his own profile expects to see his own profile updated. So let me ask you this. How often can it be stale? Can it be 1 out of 1,000,000? Can it be 1 out of 1,000? Can it be 1 out of 10,000? Can it be 1 out of 10?
You're asking an engineer, so my answer is going to be toward the latter. If you ask the product manager for the physical
No, but you as you're correct that as an engineer you're going to say, I can screw up a little more often and that's just fine. But the product guy is going to say, no, it's got to be perfect. And it's the responsibility of engineers to say, look, here's the cost-benefit trade-off, right? And I'm going to, when Dynamo was being created, I was down the hall and it was replacing 4 Oracle database engines. And if you lost one of the data, if your shopping cart was on the one that went belly up, then you got an empty cart. And so Dynamo, with occasionally a little bit staleness, which is very, very rare, is an improvement of the business needs, right? And so when you say people, do you want the wrong answer versus do you want me to take my cookies and go home and not give you an answer? That's another thing. So I'm going to push this back on you. If you update your profile, do you want the old profile? Or do you want LinkedIn to say, I ain't going to show you shit. Nothing. I'm showing you nothing because I don't know the perfect answer yet. Because those are the 2 choices you have. Do you have those choices? Now, you can say, I'm not going to do that very often, and then I'm going to talk to you about a cost knob, right? Well, then that means I got to send all this, and I got to do all this, I got to buy 20,000 more machines and 48 data centers, and wow, and we just went out of business. Crap. Maybe once in a while I'll show you the wrong profile. Did I answer your question?
Sort of, yes.
I mean,
So part of the challenge is you incur architectural complexity to have 2 different systems, one of which services the highly demand, but it doesn't have capacity.
well, one of the questions is it self-settling? One of the reasons people went into transactions and did so much work in classic databases to do transactions is because some innocent race would occur and then things just got sick after a while. And it didn't get better, it just got sick. And so if you have a system where it glitches occasionally, but it gets fine, it kind of gets better and it's okay, that's one thing. But when it gets sick and deteriorates over time, that's a bad thing. So these are the kinds of properties you want to look at when you ask these questions. Is that fair? Okay. Yes, in the back in the purple.
How much locked in will you be to each provider?
How much what?
Locked in. I mean, will you be able to change providers?
So how locked, you're talking about how locked in will you be to a provider? Will you be able to change providers? Now you're in this really interesting world. I'm going to push this back on you, which is, nope, we should never change anything in computing. No way. If we do a change, then somebody's got it different than everybody else, and so that's wrong. Right? And arguably that's where the classic Linux open systems was. Now clearly there's been some new evolution and people buy it, but then that, the locked in is a subjective, funky term. I don't have an answer for that, right? I'm talking about the technology and what it takes to provide these services. And you are correct that if you program to an API and there is only one person providing a platform for that API, that causes lock-in. But this has been around since before I was in computing, which has been a long time ago, right? And people have historically gone into multiple camps, one where they will choose not to take advantage of economically valuable features because they're afraid of only getting it from one vendor. And other folks will say, no, I will trust the vendor enough to take advantage of those valuable features. And I can't see a reason why that will change. And I am fascinated by open source. I'm not trying to denigrate it. It's just, I'm talking about what a system has to have, and then you can talk about those issues later. Am I making sense with that? And so it's unclear even in data storage APIs for infrastructure as a service like AWS versus Azure. Right now you can't read a file with the same program, okay? And that then means that you're locked in at some level unless you abstract that in your code very carefully. Do you see where I'm going with that? Right? It also means you can't replicate the data across AWS and Azure. Not easily, you can, but it's like work. And so that means that if something takes one of those two down, there was a failure that brought all of AWS down a few years back, 4 years ago or something like that, 3 years ago, which was having to do with a bug, and they rebooted and they were back up in a half a day, or 6 hours, I'm not sure. But you were at that availability. This is still a problem we haven't figured out. You see things, you use a carrier for your cell phone. And if AT&T or Verizon goes belly up, my cell phone might work separately from yours. What do you think about that? Pardon me? It's part of life right now. I don't know if I answered your question, but are there other questions?
But do you think
What?
that they will want to standardize?
Do I think that they will want to standardize? I don't think that, no, not yet. Okay, there's a normal chaos that's going on. Right now there is not a huge economic driver for the creation of the standards. Now, you can argue that a cloud provider could come along that has defined some definition of standard, right? But now you got to get the next guy to support the standard too, right? I mean, I can create a proprietary API and run to the world and say, it's open, and I'm the only one who will give you that service with that API, right? And that doesn't help you, the customer, except it might feel better, right? Do you think and that's rife in the community today. The Hadoop stuff is getting there, but it's not easy to just pick Hadoop up on your own. Most companies don't have the wherewithal to have the systems engineers to do that stuff on their own. And so you see companies that are trying to provide the infrastructural support and the maintenance support for it. You see what I mean? This is no different than back when Unix was, there were multiple schismatic flavors of Unix, right? It's the same kind of stuff. Thank you guys for your attention. Thanks for your time.